Let's go through LeetCode code 327, count or range sum. For this question, they give us an integer array nums, and let's count how many ranges the sum lies in the lower bound and up bound, and they are both inclusive. So one of the mistake for this question is that maybe someone may convert with kind of smaller, right? Smaller nums, upper minus count the smaller nums, lower minus 1, right? This is not correct because if we want to subtract those kind of ranges which is smaller equal to the upper, we are not minus all of the range, right? So, for example, we have some kind of range. They they are smaller than this kind of upper. We should count for those kind of range, right? Which is count to this, right? But if we write this, those kind of smaller, it may what we minus is an intersection, right? So this part may be different range, right? So what we need is we should for count minus those kind of intervals have a condition in this, right? So what we do for this question, normally we do for the intervals, we want to see how many intervals they follow in a range. What we think about is that we normally using the prefix sum, right? So let's see for prefix sum, right? And we can iterate use two pointers, right? And I and j, and iterate use two for loop to iterate those kind of prefix sum to get its sum of the range, right? And trying to see whether they are in the lower and the upper bounds. And doing like this, the time complexity will be O(n) squared, right? And we have this kind of time, range, it will be TRE. So what we're thinking about is that let's write, we can still reuse this kind of prefix sum. Some yes, no, what we're thinking about is that we should have better time complexity to calculate for this kind of prefix sum. For some kind of I and J range, they have some in the lower and the upper, right? To have better time complexity, one of we may think about something like n log n, right? So the sort may be one of the solution for us. Actually, for this question, the sort will be the solution, right? So if we have prefix sum, right, and this kind of array, and what we think about is the merge sort, and we already have divided conquer to different small intervals, right? So for this one, it's already been sorted. And this is also sorted, right? So assume we already sort this part and this part, okay? And then for every I, right? For this part is monotonic increasing, and this is a monotonic increasing, right? So what we do is that we just need to find, for example, prefix sum I. In this range, the prefix sum I plus lower, right? So we find this kind of J, right? And also the prefix I plus upper, right? Find this K, right? So during the merge, we know this kind of from this J and K, they will contribute every index I, they will contribute K minus J plus 1 intervals, right? So we do the merge sort, and during the merge sort, and for every I, they can have intervals, and in this kind of range, how many contribute to the total, right? So after doing this kind of merge, then we have this one been sorted, right? So now we iterate I from here and trying to find the J and the K here, add up to our total, right? So doing like the merge sort way, the time complexity will be O n log n, right? So let's write code for this. We have a temp array. We should define outside of the merge operations, right? So it should be also be n plus 1. So what we do is that we return merge sort prefix sum and the temp. We should have a lower, upper, and we should also have a start and end, right? Start is 0, end is the end. And we should have a merge sort function, right? We call this one nums. And also we have a temp and the lower and the upper and the start and the end. So if we start weight equal to n, we just return 0, right? And we are going to have int sum equals to 0, mid equals to start plus end minus start divided by 2, right? So I have sum plus equal to, here that is divide conquer, merge sort, nums, temp, lower, upper, start, mid. And also we should also have mid plus 1 to end. And then sum plus equal to, we should write a merge function, right? Nums, temp, lower, upper, start, mid, and return sum. Write the merge function, nums, right? Temp into lower, into lower, into upper, into start, into mid, into end, right? So we know for merge sort, one of the tricky things that we should do the contributions or those kind of calculations before we do the merge sort, right? So we can we can do like this. We'll have into sum, into sum equals to 0, and we can also still use a while loop while left is small equal to mid. But here I think a for loop will be better, right? For I equal start as small equal to mid, and we have j and k, right? J equals mid plus 1, and k also equal to mid plus 1, right? For int I equals start, I smaller equal to mid, I plus plus, right? So as long as this kind of j is smaller equal to n and nums j smaller than nums I plus lower, right? In this case, we're going to keep moving j. And while k is smaller equal to n and nums k, here we'll say greater, smaller equal to, right? Nums I plus upper. We'll have k plus plus, right? So after jumping this while loop, j k is included. J is included. K is just one index outside, right? So I have sum plus equal to k minus j. Then that is a regular merge sort solutions, right? So we'll have int left equals start, right equals mid plus 1. And we have I equals start. We'll have while left smaller equal to mid and right smaller equal to end, right? So we'll say if nums left smaller equal to nums right, then we'll have temp I plus plus equals nums left plus plus, right? And else temp I plus plus equals nums right plus plus. And for this, the left may not be finished, right? So we'll say y left is smaller equal to mid. Then we'll have temp I plus plus equals nums left plus plus. And also the right may not finish, while right smaller equal to end. We'll have temp I plus plus equals nums right plus plus. And after finish this kind of merging, right, we need to copy the temp back to nums. So we'll say for int L, because k used L equals start, L small equal to end, L plus plus, and we'll have nums L equals temp L, and in the end we return sum. This one, you see this kind of integer, they may be out of the range, right? So that it is a big number. Let's change this one to be long. Use long. Okay. Let's convert this one to Python code as well. So we need, for example, n equals length dot nums, right? And we are going to have prefix sum equals 0 multiplied by n plus 1, right? And what we do is for I in range from 1 to n plus 1, we are going to have prefix sum I with prefix sum I minus 1 plus nums I minus 1, okay? And we are going to have a temp array, right? Temp be defined here, multiplied by n plus 1, right? And return merge sort. We should have prefix sum array, temp array, and lower bound, upper bound, and start. The end is n, right? Let's define the merge sort function. And we have nums, okay, would be a list int, and temp should be a list int. We should have a lower should be int, upper should be int, and we should have a start should be int, and the end should be int. Need to return int. So let's say if start greater equal to end, return 0, right? So we'll have some going to have some we'll have count, okay, with count, and mid equals the count is start plus end divided by 2, right? The count is 0, right? And we'll say count plus equal to merge sort divide conquer nums temp lower upper start mid, and also we should have a count plus equal to mid plus 1 to end, and we should also have count plus equal to merge, right? Merge nums temp lower upper start mid, and so this is the merge sort, and this one should return count. And we should define another one called merge. Merge is also we need to have nums as a list int, right? So we should have temp as a list. This should be capital list int, and we should have the lower to be int, upper to be int, start to be int, mid to be int, end to be int. It also returns int, right? Here, we can define the count, right? Count j k equals 0, neither plus 1, neither plus 1, right? So we have for I in range. This is the left part from start to neither plus 1, right? We'll have while j is smaller equal to n, and nums j smaller than nums I plus lower, and then we'll have keep moving this kind of j index, right? And also while k is smaller equal to n, and the nums k smaller equal to nums I plus upper smaller equal to, right? Then k plus equal to 1, right? And we'll have count plus equal to k minus j. So this is the part to calculate those kind of ranges in this kind of merge operations, right? Then what we do is that we do the merge sort the templates, right? Left, right, and I equals start need plus 1 and start, right? And we'll say while left smaller equal to mid and right smaller equal to end. We'll say equal nums left smaller equal to nums right, right. Then we'll have temp I equals nums left, and we'll have move this kind of I index, and we need to move left index, right? And also then that is else. We have we should then we use the right part, right. So the after this while loop, the left may not be finished, right? So we also need to have while left smaller equal to mid, right? So we put this, right? And also we need a while right, while right is smaller equal to end. Then have this, right? So this is right, and we should have right plus equal to 1, right? So after this part, we do the merge, but we merge it to temporary. So what we do is that we need to copy those kind of temporary back to the nums array, right? So we'll say for L in range start and the plus 1, okay? So we'll have nums L equals temp L. In the end, what we need to return is count, right? Count. And any wrong. The time complexity will be n log n. The space is O n.